This is a demonstration of using the 9211A sampling oscilloscope to characterize a clock signal. Here I see my clock signal. I've applied this to channel 1 of the input and also to the direct trigger input. So if we look on the trigger menu, I've selected external direct in, so I'm seeing a stable trigger at this point. So I'm going to increase the time so I can see several cycles of my signal. Here I see 3 cycles of my clock signal, and I'm also going to increase the vertical sensitivity to increase my resolution. So here I see my signal. I'm also going to turn on the vector display menu so I can see the rising and falling edges. So I'm going to go display vectors. So now I can see my square wave. Straight away I can see that I've got some aberration glitch signal here on my clock, and it doesn't seem to be truly repetitive. Here I've got a positive and negative swing, here only a negative and a negative here. This could be a resolution problem, so I'm going to go into my acquisition menu, and my record length is the default of 512 points across the screen, so I'm going to increase my record length 1024, 2048 to 4096. This is the maximum number of samples available on this instrument, and we can see that now I have indeed taken more samples across the waveform. But here we can see this glitch now is truly repetitive. Each cycle looks the same, so I'm now going to zoom in and have a look at what this glitch is. So I'm drawing a zoom box, and then I click inside the box, and you see my time base has gone now to delayed, and I've got the zoomed version of the signal. So I can see there is some noise on my signal, so I'm going to go into my acquisition menu again and choose stable average and put in some more averaging to reduce my random noise. So here we see a very nice display of the signal with this aberration. So now I might like to characterize this, so I'm going to go into my markers. So the first thing I would like to do is measure the amplitude, so I'm going to go into the Y direction and place my cursors on the positive and negative peak. And so I've got something like 48 millivolts peak to peak. I could also measure the frequency of this ringing. So for that I'll use my X cursors and place them on one cycle of the ringing. Put my cursor 2 there. So this appears to have a frequency of somewhere around 450 megahertz. If I'd like to characterize the frequency exactly, I could use the measurements mode. So I will turn off my markers and go to measure and measurement parameters, and I can measure X and Y parameters. I want to measure frequency, which is X parameter, so I will select measure frequency, and here is where my measurement is going to be made. So I only want to make it on my signal, so I lower the top limit. So now it's automatically selected a cycle of the ringing here, and I've got a left crossing and a right crossing, and it's measured my frequency to be exactly 510 megahertz. So hopefully a designer could use this information and go and look at his clock signal and remove this random signal from his clock.